Welcome back to the workshop. Today we are restoring a heavy-duty reducer housing. The heavy-duty reducer housing is transported across the workshop with the help of an overhead crane. Because of its massive weight, using a crane is the safest and most efficient way to move the component between workstations. The crane operator moves the load slowly and smoothly while keeping the housing balanced at all times. Technicians guide the suspended component using tag lines, preventing unwanted swinging and ensuring safe movement through the workshop. The reducer housing is carefully transferred from the welding area to the machining and restoration section, where the next stage of work will begin. Every movement is closely monitored to avoid contact with machines, tools, or other equipment. Before any welding begins, the damaged area of the heavy-duty reducer housing must be prepared with extreme care. Proper preparation is one of the most important steps in the restoration process because the strength and durability of the final repair depend on the quality of the surface preparation. A clean, properly prepared surface allows the weld metal to fuse completely with the base material, creating a strong and reliable repair that can withstand heavy loads and continuous operation. The restoration begins with a detailed inspection of the reducer housing. The technician carefully examines the entire component to identify cracks, broken edges, worn mounting surfaces, corrosion, impact damage, and any signs of metal fatigue. Every damaged area is marked so that no defect is overlooked during the repair process. Once the inspection is complete, all grease, oil, dirt, and contaminants are removed using industrial degreasers and cleaning solvents. Heavy-duty reducer housings often operate in harsh environments where years of oil leakage and dust build up on the surface. These contaminants must be completely removed because they can contaminate the weld and reduce its strength. After cleaning, the damaged section is prepared using an angle grinder fitted with a grinding disc. Rust, old paint, oxidation, and loose metal are removed until clean, bright metal is exposed. The technician continues grinding until every trace of contamination has disappeared. Next, the cracks are opened using a grinding wheel to form a V-groove. This groove allows the welding filler metal to penetrate deeply into the damaged area, producing a stronger bond between the old metal and the new weld. The groove is made carefully to achieve the correct depth and angle without removing unnecessary material. Any broken edges are trimmed and shaped to create a smooth welding surface. Sharp corners are rounded slightly to reduce stress concentration after the repair. Loose fragments. After the heavy-duty reducer housing has been fully machined, it enters one of the most important stages of the restoration process: precision inspection and balance verification. At this point, the component has regained its original shape through welding and machining, but every critical dimension must now be checked before it can be approved for assembly. The machining team begins by cleaning the reducer housing thoroughly. Metal chips, cutting fluid, grinding dust, and machining residue are removed from every surface, oil passage, and bearing bore. A clean component makes inspection more accurate and prevents contamination during assembly. The technicians then carry out a detailed visual inspection. Every machined surface is examined for scratches, chatter marks, cracks, tool damage, or machining defects. Special attention is given to the bearing seats, mounting faces, sealing surfaces, and bolt holes, as these areas directly affect the performance of the reducer assembly. Next, precision measuring instruments are used to verify the dimensions. Vernier calipers, outside micrometers, inside micrometers, bore gauges, dial indicators, straight edges, and feeler gauges are used to compare the finished component with the manufacturer's specifications. Every measurement is recorded as part of the quality control process. The bearing bores are carefully measured to ensure they are perfectly round and within the required tolerance. Proper bearing fit is essential because even a small dimensional error can cause premature bearing failure, excessive vibration, overheating, and gear misalignment. The mounting surfaces are checked for flatness using precision straight edges and dial indicators. Flat mounting faces ensure that the reducer housing fits correctly during assembly without creating unnecessary stress on the gearbox. The technician also checks the alignment between all machined surfaces. Correct alignment allows the gears, shafts, and bearings to operate smoothly. The heavy-duty reducer housing is ready to be transferred to the machining section. Every welded area has cooled naturally, allowing the metal to regain its strength before handling. The workshop team performs one final inspection to make sure the repair is complete and that the housing is safe to move. Unlike workshops equipped with overhead cranes or forklifts, this operation is carried out entirely by experienced workshop workers. Teamwork, careful planning, and proper lifting techniques are essential because the reducer housing is a heavy industrial component that requires complete control throughout the movement. Before touching the component, the team clears the working area. Loose tools, welding cables, scrap metal, and other obstacles are removed from the floor to create a safe path between the welding station and the machining machine. A clean work area reduces the risk of slipping or losing control of the heavy housing. The workers gather around the reducer housing and discuss the moving plan. Each person is assigned a specific position and responsibility. One worker leads the operation, giving clear instructions while the others coordinate every movement. Good communication is essential when moving heavy equipment manually. The housing is carefully lifted a small distance from the support blocks. Every worker applies force at the same time to keep the component balanced. Sudden lifting or twisting is avoided because it could place unnecessary stress on the newly repaired welds. The team slowly begins moving the reducer housing across the workshop floor. Every step is taken with caution. The workers maintain a firm grip while carefully watching the path ahead. They're moving. Completed, the heavy-duty reducer housing undergoes a balance check to ensure it is ready for the next stage of restoration. The repaired component is carefully placed on a heavy-duty balance scale, where its weight and weight distribution are verified. This inspection helps confirm that the welded repairs have not caused excessive imbalance or uneven material buildup. The technicians carefully observe the readings and compare them with the required specifications. If necessary, excess weld material is marked for grinding and machining to restore proper balance. Most important quality control stages of the restoration process, the balance check. This inspection ensures that the repaired component is properly restored and ready for final assembly. Even a small imbalance can cause vibration, uneven wear, bearing failure, gear misalignment, and reduced service life. For this reason, every balance inspection is performed with great care and precision. The process begins by thoroughly cleaning the reducer housing. All metal chips, grinding dust, cutting fluid, grease, and dirt are removed from the surface. A clean component provides more accurate inspection results and prevents contamination during measurement. The technicians first carry out a detailed visual inspection. Every repaired area is checked carefully for cracks, porosity, incomplete welds, excessive weld buildup, or machining marks. Bearing seats, mounting flanges, seal surfaces, and bolt holes are inspected to ensure they are free from defects. Once the visual inspection is complete, the reducer housing is moved to the balance inspection station. The component is carefully positioned on a heavy-duty balance scale. The technicians make sure it is sitting correctly before taking any measurements. The total weight of the housing is recorded and compared with the required specifications. This confirms that the welding and machining processes have not removed too much material or added unnecessary weight. Maintaining the correct weight is important for the overall performance of the reducer assembly. After checking the weight, the technicians inspect the balance of the component. The reducer housing must remain stable and evenly supported. This additional material provides enough stock for precision machining, allowing the component to be restored to its original factory dimensions. Before machining begins, the reducer housing is mounted securely on a heavy-duty lathe or boring machine. The machinist carefully aligns the component using dial indicators and precision measuring tools. Proper alignment is essential because even a slight error can affect the bearing seats, gear alignment, and overall performance of the reducer. Once the setup is complete, the machinist tightens the clamps and performs a final inspection. Every mounting point is checked to ensure the housing cannot move during the cutting operation. Safety guards are positioned, and the machine is prepared for operation. The machine is started at a controlled speed. As the spindle begins to rotate, the cutting tool is positioned close to the welded area. The machinist slowly advances the cutting tool until it makes its first contact with the excess weld metal. Bright metal chips begin to form immediately as the cutting tool removes the extra material. Each pass is smooth and controlled, producing a clean, continuous cut across the repaired surface. The purpose of this operation is not only to remove excess weld material, but also to restore the housing to its original dimensions. The cutting depth is adjusted carefully throughout the operation. Removing too much material in one pass can create unnecessary stress on the cutting tool and reduce machining accuracy. Instead, the machinist removes the excess material. After all welding, machining, grinding, and precision measurements have been completed, the heavy-duty reducer housing reaches the final stage of the restoration process. This is the moment where every hour of hard work is carefully inspected to ensure the component is ready to return to service. The technicians begin with a complete visual inspection. Every machine surface, mounting flange, bearing seat, oil passage, and sealing area is checked carefully. They ensure there are no cracks, sharp edges, machining marks, or surface defects that could affect performance. Next, all critical dimensions are measured one final time using precision instruments. The bearing bores, mounting faces, and alignment surfaces are compared with the manufacturer's specifications. Every measurement must fall within the required tolerance before the housing can be approved. The entire reducer housing is then cleaned thoroughly. Metal chips, cutting fluid, dust, and polishing residue are completely removed. Every oil gallery and threaded hole is cleaned. Thank you for watching. If you enjoyed this heavy-duty restoration project, don't forget to like, share, and subscribe for more.